Welcome back from the ad break, and let's continue with our lesson. Now we are going back to that concept map where we are going to look at our first concept, and that is the parallelogram. So let's look at a parallelogram focusing on the angles and the diagonals. Now we've already discussed the sides of a parallelogram, and we know that the opposite sides are parallel and the opposite sides are also equal as well. So when looking at the angles, we see here that the opposite angles of a parallelogram are equal. So the opposite angles of a parallelogram are equal. That is going to be angle D and angle B. So those opposite angles of a parallelogram, they are equal. So before we can look at the diagonals, and remember what a diagonal is. Now, a diagonal is a line that goes from one vertex to another vertex, so on opposite vertices of a polygon. So before we can look at the diagonals and what those diagonals mean, let's just recap the properties of a parallelogram. So that is, when it is concerning the sides, we know that AB will be equals to CD, and of course AD will be equals to BC, as discussed earlier in the lesson. And also they are not only equal, but they are also parallel. So that means that AB is parallel to CD, and again AD is parallel to BC. And of course, when it comes to those angles, we said there that angle A is equals to angle C. Why are we saying this? Because they are opposite each other, so those opposite angles are equal. And of course, that also means that angle D and angle B are also equal. Why? Because this is a parallelogram, and in a parallelogram, the opposite angles are equal. So let's look at those diagonals. So when looking at those diagonals, we can see that because we said a diagonal goes from one vertex to another vertex in a polygon, then we can see there that AC is a diagonal. Again, DB is also a diagonal, and where they intersect, we will say that is a point T, but that is the point where the two diagonals meet, and that is the point of intersection for our diagonals. Now, what do we know about these diagonals? Well, firstly, we know that the diagonals of a parallelogram bisect each other. And you remember, to bisect is to cut into two equal parts. So because they meet at T, that means that at T is the point where they bisect each other. Now this means that the length of AT will be equals to the length of a TC. So whatever the length is with AT, that length will be the same as the length with a TC. What about the other diagonal, DB? The same applies for DB as well, to say that BT, which is that length over there, BT would be this one over there. So that length over there will be equals to the length of DT, and that is that length over there. So they will be equal. And that is those are the diagonals of a parallelogram. They bisect each other. So the angles, opposite angles are equal, and then the diagonals, they bisect each other. So the properties of a parallelogram is that the opposite sides are parallel, the opposite sides are equal, the opposite angles are equal, and the diagonals bisect each other. And those are the properties of a parallelogram. Let's look at an activity that needs us to use these properties to solve for unknown angles. The following here says, the parallelogram below has one given angle, angle A, which is 124 degrees, and DB, which is equals to 18 centimeters. So as we can see from the given information, we have been given the whole angle of A, which is 124 degrees, and then we've been given DB, which is the diagonal. So we need to calculate the following. The size of C. Now when we look at C, we can see that it is opposite angle A. Now given that this is a parallelogram, what do we know about the opposite angles of a parallelogram? Yes, you are correct if you are thinking that they are equal. So this means that angle C is equals to angle A, which is equals to 124 degrees. And the reason for that would be that they are opposite angles of a parallelogram. So angle C is equals to 124 degrees. Then we are required to calculate the size of angle D. Now remember, this is a parallelogram. So this means that the opposite sides are parallel. So that means that AB is parallel to DC, and it means that AD is parallel to BC. Now, let's look at where angle D is. So we are required to find the size of angle D. Now, angle D and angle A, they are co-interior angles, and this is because of those parallel lines. So we can say here that angle A plus angle D is equals to 180 degrees, and this is because they are co-interior angles, and we know that co-interior angles add up to 180 degrees, and this is only possible because of those parallel lines. The AB is parallel to DC. So we know that angle A plus angle D is equals to 180 degrees. So we already are given that angle A is 124 degrees. We are looking for angle D, and this, or the sum of these two angles, is 180 degrees. Now we are going to use the additive inverse of 124 degrees, and we are going to use that to solve for angle D. So angle D will be equals to 180 degrees minus 124 degrees. This means that angle D will be equals to, well, if you are thinking of 56 degrees, then you are absolutely correct, because 180 degrees minus 124 degrees is equals to 56 degrees, and that is the size of our angle D. Let's calculate more angles in that parallelogram. Now, given the same parallelogram, remember, we just calculated that angle C is 124 degrees, and we calculated that angle D is equals to 56 degrees. Now, in the information, we were given that DB is equals to 18 degrees. Now, remember, DB is that diagonal. So we can note there that the size of DB is 18 centimeters. Now let's look at what we are required to calculate next. So next we need to find the size of angle B. Now the size of angle B is opposite angle D, or angle B is opposite angle D. So what does this mean? Since this is a parallelogram, that means that angle B is equals to angle D, and since we just calculated that angle D is equals to 56 degrees, that means that angle B is also equals to 56 degrees. And this is because they are opposite angles of a parallelogram. they are opposite angles of a parallelogram. So angle B is equals to 56 degrees. What else are we required to calculate? We are now required to calculate the length of DT. Now, if we look at where DT is part of DB. And we have been given the length of DB, which is 18 centimeters. Now, DB is a diagonal of a parallelogram. And what do we know about diagonals of a parallelogram? Yes, we know that the diagonals of a parallelogram, they bisect each other. And since as well we can see that they bisect each other at T, that means that the length of DT is equals to the length of TB. And since the whole DB is equals to 18 centimeters, then that means that DT is half of DB. So DT is half of DB. And what reason do we have for that? Our reason will then be that the diagonals of a parallelogram bisect each other. They bisect each other. So what does this mean? It means that DT is equals to half of 18 centimeters, which will give us a final answer of saying that DT is equals to 9 centimeters. So now we know that DT is equals to 9 centimeters. So now we've calculated all the angles in this parallelogram, including one of the, or half of the diagonals. Now, a question that is raised here is, what do you notice when you add all the interior angles of this quadrilateral? That is, if we take angle A, we add it with angle B, and we add it with angle C, and we add that with angle D. That would be 124 degrees plus 56 degrees, because we found angle B to be 56 degrees, plus 124 degrees for angle C, and lastly 56 degrees for angle D. What do you notice about the sum of the interior angles of this quadrilateral? If you are thinking that they add up to 360 degrees, then you are correct, because all of the angles inside this quadrilateral, the interior angles, they all add up to 360 degrees. So remember, the diagonals of a parallelogram bisect each other. That's how we were able to find the length of DT. And as for those angles there, when we add the interior angles of this quadrilateral, they add up to 360 degrees. Let's quickly go to an ad break, and then we'll see you just now for more of those quadrilaterals.